Okay, so this problem reads, helicopter blades withstand tremendous stresses. In addition to supporting the weight of a helicopter, they are spun at rapid rates and experience large centripetal accelerations, especially at the tip. What is the magnitude of the centripetal acceleration if the 4-meter long helicopter blade is rotating at 300 revolutions per minute? All right, so part A is asking us for that centripetal acceleration, which is equal to the angular speed squared times the radius. We want to remember that angular speed has to be in radians per second. So we're going to convert our revolutions per minute to radians per second. So we have 300 revolutions per minute. I know that in 1 minute there are 60 seconds, and there are 2 pi radians for 1 revolution. So my 300 revolutions per minute turns into 31.4 radians per second. All right, so once I have my radians per second, I can use my centripetal acceleration relationship. 31.4 squared times the radius of 4 gives me a centripetal acceleration of 3.95 times 10 to the third meters per second squared. All right, and it asks what is the, part B says, what is the linear speed at the tip? So I'm getting a little ahead of myself. Part B asks for the linear speed at the tip. We know the linear speed can be obtained by taking the angular speed times the radius. So our angular speed is 31.4, our radius is 4, and we have a linear speed at the tip of 125.6 meters per second. All right, and then it asks us to compare that to the speed of sound. Well, the speed of sound is equal to 343 meters per second. So that's about 1/3 the speed of sound. All right, so recognizing we need to be in radians per second to use our relationships, and then determining that centripetal acceleration as well as our linear speed. Good job.